So as a little more in theory about biomaterial making. I don't know how many of you have had any experience with it, but biomaterials, as the name pretty much let us know, it's a material that's bio-based, and most of them are biodegradable. Not all of them are as easy to degrade as just leaving them out in the nature, because we have two different, well, there are a lot of sub-classification as well, but one of the main sub-classifications of a biomaterial are this one. It's from agropolymers and biopolyesters, and it's both are biodegradable and bio-based materials, but they come from a different source. And the first ones are literal nature agricultural products made into something new, based with the base with what they are made is starch, cellulose, like proteins, and this is the kind of biomaterial that you can basically leave in the nature, and just wind and rain would degrade it. And then we also have biopolyesters, which the base of them are a structure that's comes from polyester structures. An example of this would be PLA, like the material that's most commonly used for 3D printer, which is it comes from an organic base, but it is only biodegradable under very specific conditions. Here you can check out some other examples of these biomaterial differentiation, and we also can differentiate the biomaterials if we craft them or we grow them, right? We can mix the material into making something like bioplastics, biosilicones, also some leather that can be made with kombucha or seaweed, or we can also grow materials with organic stuff. Here we have some examples. These examples were made by designers, and that's kind of the idea why they are like very well finished products, but all of them are made with biomaterial that they craft them. And the base of crafting materials, biomaterials, it's mixing three main components. We always have a biopolymer, which is the base of the material. It can be animal or also can be vegetal, coming from the plant world. And we also always add some plasticizer, which most of the times we use glycerin or glycerol, and we also will add a solvent as a main liquid body. Also, this is going to be like the base of the material. We can also, as I was explaining before, for adding texture, color, and different behaviors, we can add additives. And here is when we can also take on the circular part by picking up wood dust and food leftovers, anything that's waste. We can actually like make it into smaller parts and include it into these biomaterials. The main process and fabrication, the main fabrication process would be always a part of mixing. Sometimes we need heat in order to dissolve and mix the materials. Then we'll need to cast as the process of pouring something that's liquid into a container that's gonna hold it during the process of this liquid material to become solid. Then we'll most of the times need a drying process. It takes from 3 days to 1 week, or maybe even 2 weeks, depending on the material that we are doing. and we can do it just by leaving them in a very ventilated area, or sometimes when we're working with very specific conditions, we might need to control them. And there are like other options like the hydrators or fridge. The post-processing implies once we have the material and working it around it to make it into a product. We can laser cut it, we can saw it, different options. This is again a little idea on how to do this process. We just also have the option of doing molding and casting as a part of the casting. It doesn't only have to be into a 2D. We can have a laser cut mold or an embroidery hook where we can just pour the material, or we can work with a proper mold. Then this is the first recipe. This is the easier recipe to do. So if you have never worked with biomaterials before, I encourage you to do the gelatin option first, because it's definitely the easier one. Here you have some videos and also the recipes and the quantities that you have to use in order to make it. The videos are very easy to follow up. So, I mean, it's most of the times it's just like cooking, right? It's just mixing, heating a little bit, and then just pour it. So the process is pretty straightforward. It's more about trying to do it with calm and leave it into a nice ventilated area. The other option we're proposing you is the agar based. Agar on the contrary of gelatin that comes from, it's an animal source. This is a plant source. It is seaweed. And the idea is the same. We just mix it with water and glycerol. Here, this is the same structure of the recipe as the gelatin one. It gives you 3 amounts of glycerol depending on the flexibility you want to achieve, right? If you want to achieve a more rigid material, you add less glycerin, and if you want it to be more flexible, you'll add more glycerin to it.
Super. Yeah, we are almost ending the biomaterials presentation. So we present you 2 recipes that, Julia, can you? We presented to you 2 recipes that I think so from our, let's say, experience, they are the most easy one to start. But there will be in the resources that we will share to you a document where you will be able to follow other recipes if you are interested. Okay. So the idea of this week activity is to experiment with the biomaterials making. So I just collected a video that more or less shows again the same processes that Julia was explaining to you, but in a kind of like step by step and putting in a mold that are going to be similar as the ones that you will have to do. So this is the process. As you can see, Julia says it's kind of like cooking, and it depends of the quantity of the different 3 ingredients that she mentions. You will get more flexibility or less, and this is the pouring time. And this is the pouring, let's say, process. In that case, is with the gelatin, with the acrylic, let's say, mold. But you can experiment with so many, let's say, materials. Okay. Next to this presentation, we will send it to you 2 other documents, one that is after creating biomaterials and another one that is before and after creating biomaterials, and are considerations that you have to have in mind when you are preparing, let's say, the recipes. In here, basically, again, you are seeing the pouring process, let's say, of creating a sheet of these biomaterials. Okay. This, when it's done, you can demold, let's say. in that case, as you can see, let's say the frame was made out of wood because the gelatin one needs to be stick, let's say, a little bit more than the agar. Oops, sorry. And we recommend you to add this, let's say, pouring off. And the idea is that after you have this material, that here you can see how it's cut it, let's say, with a knife, then you have something that you can work on. Okay, so you can do so many things. For the ones that you already had experience creating basics biomaterials, so we challenge you with a kind of a more advanced practice, and we know that we still didn't see 3D printing as a technique, but if you already had that experience, so we challenge you to create your 3D printing mold in a way. You can see here the process. So this is made out of PLA and then with a little bit of olive oil, but you can use another oil. And then what you see in green color, this is a bio silicone. That is the same recipe of gelatin, but with the proportions a little bit, let's say, change it to have more flexibility. You can see here the process of the molding, okay? And then as an output, I was putting a material that is clay. How is the yeso?
Plaster.
Plaster. It should be a material that it's not hot, because if it's not, it will yeah, break the mold again. But it was working very well. So this is the, let's say, the challenge for the ones that you have experience. And also I share also here some, let's say, some resources in case you want to use, for example, TinkerCAD to do it. But as I mentioned it, so this is just an extra task, okay? In terms of references, I want to just highlight this one. I really like it because it's a way to create 3D molds out of 2D fabrication. So using the unfolding type. And even if you can basically download and cut it, let's say manually, you can also create your ones and you can cut it with the laser or with the vinyl cutter, okay? And this is another reference. This is a project that basically they are doing a press fit construction kit, the ones that we suggest you to do, or something that we suggest you to do the previous week, but with a biomaterial. In that case, it was a potato, a slice of potato, but it could be done, let's say, with any of the sheets of biomaterial that you will create, okay? Some other references, if you are interested in the topic, in the bio fabrication, let's say, Fabricademy it's a academy, let's say, program that have a lot of examples of different students applying biofabrication in different topics, and I just let you hear a video of the different examples, okay, for the ones that you are interested. And some other links that maybe you would like to check.